Welcome to Teleschool programs. Good morning children. Once again a very warm welcome to yet another interesting session of physical science, reflection of light at curved surfaces. Children, in the previous class we have learnt about the lab activity where we found the different kinds of images formed for different object positions in front of a concave mirror. We also went to draw ray diagrams for these object and image positions. Children, let us have a brief review of the previous session. In the previous session, we have seen the lab activity whose aim was to observe different types of images formed for different object positions in front of a concave mirror. So, what all did we use children for the experiment? We made use of the concave mirror of a certain focal length, it was 20 centimeters. We made use of a V-shaped stand to place the mirror. Then the candle, we made use of a candle which acted as the object. We made use of a white sheet which was acting as a screen and a scale for all the necessary measurements. So, this was the aim and the material required for the experiment. Then what was the experimental setup? The experimental setup was in this way. We placed the mirror at a certain position. The place of the mirror was fixed and we placed the object, that is the candle, at a certain distance. We tried to observe the images at various positions by changing the object position. So, children, we have noticed that there was a difference in the image formation for different object position. Let us have a fast view of the different kinds of images as well as the ray diagrams together. Children, this is the first position. Look at the first diagram. The object was placed between P and F, that is pole of the mirror and the focus. The image formed at behind the mirror. Okay. So, children, if you observe here, we had to extend the rays backwards to get the image, which means that it is a virtual image. It is not a real image, children, it is a virtual image. This is much more bigger compared to the object and it is upright and erected. Now, children, we moved on to the second position. In the second position, if you look at the object position, the image is forming at infinity. The image is forming at infinity. The object is at F. So, the image is forming at infinity. Okay, children? The third position, moving the object farther away from the mirror. We have kept the object between the focus and the center of curvature, between F and C. So, where is the image forming, children? Yes, the image is forming beyond C. How is the image? Yes, the image is enlarged, the image is inverted and it is a real image. How can we say it is a real image? If you remember, children, we caught this image on the screen. Yes, children? Similarly, if the object was on C, the image also formed on C, that is the same position. Here, the image and the object are of the same size and the image is again real and inverted. What are you noticing, children? Yes, as the object is moving away and away from the mirror, the image is getting closer and closer. At the same time, the size of the image also decreases. Now, look at this position, children. The object is placed beyond C, that is, it is farther away from the mirror and image forms between F and C. Now, the size of the image is diminished as well as it is real and inverted. One final image, children, when the object is very far away, when the object is at infinity, all the light rays meet at focus. Yes. So, a highly diminished image forms at the focus. Again, this is real and inverted. So, children, this was what we have learnt in our previous sessions. So, today we are going to learn about the mirror formula. The mirror formula, a mathematical relationship between F, the focal length of the spherical mirror, U, the object distance, and V, the image distance. And the formula is given by 1 by F is equal to 1 by V plus 1 by U. Okay, children? This is also called as the mirror equation. So, children, in order to apply this formula or use this formula to find any unknown value, first we have to know where we have to take the positive sign and where we have to take the negative sign. The knowledge of this is utmost important for us. For this, we are going to learn the sign conventions. Yes, children, yet another important concept in today's class is the sign convention. The first rule of the sign convention: all measurements to be made starting from the pole of the spherical mirror. Okay, children, that is, whether you are measuring the distance towards the right of the mirror or towards the left of the mirror, you have to take the pole of the mirror as the origin. So, let us see this. See here, children. If the object is placed in front of the mirror, obviously the object is placed in front of the mirror, then the direction of measurement is from the pole towards the object, from the pole towards the object. And at times we have to make measurements behind the mirror also for, let us say, virtual images. At that time the measurement has to be done in the other way, again starting from the pole of the mirror. Okay, children, I hope you understand this. All measurements are to be made starting from the pole of the mirror. This is the first and foremost rule of sign convention. Now, let us go for the next one. All distances measured in the direction of the incident ray are taken positive, and those measured in the opposite direction of the incident ray are taken negative. Let us try to understand this in a better way. Observe this, children. The object is placed at a certain distance from the mirror. Yes, children, for convenience we are taking the concave mirror. In the concave mirror, the focal length lies in front of the mirror itself. So, now if you have to measure the focal length and the object distance, then what are the direction we have to take and what sign do we get? First of all, we know the direction of incident ray is towards the mirror. Say this, children. This is the direction of the incident ray. Now, the measurement of both the focal length and the object distance has to be done in the opposite direction. Yes or no? Now, observe this, children. The direction of measurement of both the focal length and the object distance is in the opposite direction of the incident ray. Okay? What does this mean? According to rule number 2, we can understand that for a concave mirror, the focal length and the object distance are to be taken as negative. If the image is a real image, it forms in front of the mirror only. The direction of the incident ray is towards the mirror. Yes, children? And what about the measurement of the image distance is in the opposite direction of the incident ray. That means, for a real image, the image distance is taken as negative. The distance of a real image is measured in opposite direction to the incident ray. Hence, for a real image, the distance is taken negative. The image distance is taken negative. Next, children, what if it is a virtual image? We know that concave mirror also forms a virtual image. When does it form a virtual image? Yes, when the object is placed between P and F, the mirror forms a virtual image which is behind the mirror. Now, let us see the directions. The direction of the incident ray again is towards the mirror. Okay, children? If the mirror was not there, then the direction of the incident ray would be continuing in the same direction. And now, let us see the direction of the image distance measurement. Here, the virtual image measurement is also in the same direction as the incident ray. Therefore, we can say that the distance of a virtual image is measured in the same direction as the incident ray. Hence, for a virtual image, the distance is taken positive. Okay, children? This applies for a convex mirror also. For convex mirror, we know that the focus, the center of curvature lie behind the mirror. Okay, children? Therefore, they all are taken positive. Only the object distance is negative. Distances measured in front of a spherical mirror are taken as negative, whereas distances measured behind the mirror are taken as positive. Okay, children? This applies to both concave and convex mirrors. Now, children, we will talk about the heights. what are the heights? What do we have to do about heights here? Children, when we are considering object and image, we are considering them in different sizes. Yes children, for a certain object size, we are getting different sizes of images. Okay? So, in order to understand how the image is changing with respect to the object position or the object size, we are having the third convention based upon the heights of the object and images. All heights measured above the principal axis are taken as positive, whereas all heights measured below the principal axis are taken as negative. Now, let us understand this for object and different images. See here children, the height of object is taken as positive. Why children? Object is always placed above the principal axis. Yes or no? Object is always upright. It is kept above the principal axis. So, the measurement of the object height is always in the upward direction. So, height of the object or size of the object is always taken as positive. Okay children? Now, what about a virtual image? A virtual image is also erected. A virtual image is also erected. It is upright. Okay children? Just like the object, it is upright. It may vary in size. The measurement is taken in the upward direction of the principal axis. It is measured above the principal axis. Therefore, the height of the virtual image is taken as positive. Okay children? So, always the height of the object is positive and the height of the virtual image is taken as positive. Now, what about a real image? What about an inverted image? A concave mirror mostly forms an inverted image. Yes children? So, you can see an inverted image here, and if you have to measure this image, the height of this image, then the measurement has to be in the downward direction of the principal axis. The measurement is taking place below the principal axis. Is it clear children? What does it mean? Measurement below the principal axis has to be taken negative. That means height of the real image, height of the inverted image is taken as negative. Is it clear children? So children, I hope you have understood all the three rules properly. Let us try to put them together here. In the sign convention table, object distance is negative for both concave and convex mirrors. The image distance is mostly negative for a concave mirror except in the case where you get a virtual image, that is when you keep the object between P and F, only in that case we have the image distance as positive, otherwise in all other cases it is negative. For a convex mirror it is positive, image distance is always positive. Focal length is always negative for a concave mirror and always positive for a convex mirror. Similarly, height of the object is always positive for a concave mirror and always positive for a convex mirror. And height of the image is negative for a concave mirror except in one case where it forms a virtual erected image. Okay? In the first case where object is between P and F, only in that condition we have the height of the image taken as positive, and for a convex mirror the height of the image is always positive. So children, if you make use of this table properly, then solving the problems will be very simple for us. Based on this, let us try to do a numerical problem. In this problem, we have to find the nature and position of image formed when an object is placed at a distance of 15 centimeters from a concave mirror of focal length 10 centimeters. A very simple problem children. Now, from our tabular column, we know that for a concave mirror, object distance and focal length have to be taken as negative. Therefore, u is equal to minus 15 centimeters and f is equal to minus 10 centimeters. We have to find out v, that is the image distance. The mirror formula here we are using 1 by f is equal to 1 by v plus 1 by u. Now children, substituting the values in the formula, we have 1 by minus 10 is equal to 1 by v plus 1 by minus 15, and 1 by V is equal to 1 by minus 10 plus 1 by 15, that is U is sent on the other side of the equation. So, we have 1 by V is equals to 1 by minus 10 plus 1 by 15. On solving this, we will get 1 by V is equal to minus 1 by 30. On solving this, we will get 1 by V is equal to minus 1 by 30. Therefore, V is equal to minus 30 centimeters. V is equal to minus 30 centimeters. What does this mean, children? Minus 30 means it is formed in front of the mirror only, which means it is a real image and it is an inverted image. It is a real and an inverted image. I hope you understood this problem, children. It is a very simple problem. Next, children, we are going to learn about another important term called as the magnification. Why do we have to learn about magnification? See, children, there is a difference in the sizes of the object and image. So, we have to learn what is the ratio or what is the amount of increase or decrease in the size of the image compared to the size of the object. The size of the image formed by a spherical mirror depends on the position of the object from the mirror. As the object is moving away and away from the mirror, the image is coming closer and closer to the mirror, and at the same time the size of the image is also reducing. Therefore, the size of the image depends upon the position of the object from the mirror. The second point, the image can be bigger than the object, equal to the object, or smaller than the object. The image can be bigger than the object, equal to the object, or smaller than the object. This also we have seen in our activity, that the image can be of various sizes. It can be a magnified image, it can be the same size, or it can be a smaller image compared to the size of the object. The ratio of the size of the image to the size of the object is called magnification. The ratio of the size of the image to the size of the object is called as magnification. Children, this is the definition of magnification that we have to remember. M is equal to HI by HO is equal to minus V by U. This is the formula for magnification. Magnification here is defined in two ways here. It is defined either as the ratio of the height of the image to the height of the object, or it is defined as the ratio of the negative of the image distance to the object distance. So, children, after learning the formula for magnification, let us look at simple problem to solve using the magnification formula. In this problem, the object height is given as 4 centimeters. An object of 4 centimeters in height is placed at 25 centimeters in front of a concave mirror of focal length 15 centimeters. So, children, we have an object whose height is 4 centimeters. The object is placed at a distance of 25 centimeters and the focal length of the mirror is 15 centimeters. So, children, we have to make use of two formulae here, that is the mirror formula as well as the magnification formula. Now, we have to find the image distance V and height of the image HI. Children, using the mirror formula and substituting the values in the formula, 1 by F is equal to 1 by V plus 1 by U. F is minus 15 centimeters, U is minus 25 centimeters. Substituting here, we have 1 by minus 15 is equal to 1 by V plus 1 by minus 25. So, I can write 1 by V is equal to 1 by 25 minus 1 by 15. On calculating, we have 1 by V is equal to minus 2 by 75. Yes, children, you have to subtract this equation using LCM. That gives us V is equal to minus 75 by 2. Yes or no, children? The reciprocal of V, it will become minus 75 by 2. Therefore, we have the image distance V is equal to minus 37.5 centimeters. Okay, children? From this, what did we understand? the image is formed beyond C. Yes children, that means it should be a real image and it should be an enlarged image. So, let us see if we are getting an enlarged image or not. M is equal to HI by HO is equal to minus V by U. This is the formula for magnification. So, HI by HO, HO is equal to plus 4, we got that. So, HI by 4 is equal to minus V. V is already minus 37.5 children. So, it will be minus of minus 37.5 divided by U is minus 25. Therefore, HI is equal to minus 37.5 into 4 divided by 25. On calculating, we get HI is equal to minus 6 centimeters. We get HI is equal to minus 6 centimeters. So, children, the height of the object was 4 centimeters and height of the image we got as 6 centimeters. Minus sign here indicates what children? It is inverted image. Yes, minus sign indicates it is an inverted image. And if you see, the image is enlarged compared to the object. 6 is greater than 4 children. Yes. So, height of the image is enlarged compared to the object. So, compare these properties to the object placed between F and C. You will be able to tally all the values. Now, children, you might have learnt that it is a legendary story about Archimedes burning ships, the enemy ships, by using a mirror. So, here what kind of mirror do you think it was? Any guess children? Yes, it was a concave mirror. So, it is believed that Archimedes took help of large concave mirrors and adjusted them in such a position that the reflected rays of sun fell on the ship, on the enemy ship. It was adjusted such that the reflected rays coming from the sun are focused at the enemy ship, and after a certain time the ship started burning. This is a legendary story children. If not burning ship, can we at least try to cook something using a concave mirror? Why not? We are already making use of this phenomena in the form of a solar cooker. Yes children, what are you seeing in the image? The person here is trying to heat up water or cook something in the bowl by placing it in front of a parabolic solar cooker. Yes children, this is called as a parabolic solar cooker. Now, let us try to understand how we can make this solar cooker. So, first of all, try to observe the image clearly children. How is the shape? This is in the shape of our dish antenna. Now, observe the reflecting surface children. Is it a continuous sheet? No children. It is made up of triangular sheets. The mirror sheets are triangular sheets which are joined together on the dish. So, based on this, let us try to understand the making of a solar cooker. We have to take a large wooden or iron frame which is in the form of a dish antenna. Cut 8 to 12 acrylic mirror sheets. They are available in the market children. Acrylic mirror sheets in the form of isosceles triangles. See here children, for your understanding, I have kept here isosceles triangle shaped. What do we mean by isosceles triangles children? Two sides are equal. Okay children, the two sides are, any two sides are equal. So, we place these triangles in such a way that the height of the triangle is equal to the radius of the dish, and the bases of the triangles together make the circumference of the dish as you have seen in the image. Now, stick the mirrors together, arrange so that the concave part faces the sun. Now, the concave part of the dish has to face the sun so that it receives solar energy and transmits it to the vessel. We have to find the focus of the vessel and place the vessel at that point. Now, see here children, in the image here, in the image you can see we have the focus of the parabolic shaped cooker here, okay, the parabolic shaped cooker, and this is the focus. So, we have to find this focus and place the vessel exactly at the focus so that all the light rays are getting reflected and converging at that point only. Once again, see this children, the image, a kettle is kept exactly at the focus of the parabolic shaped cooker. Okay. Now, this vessel gets enough heat to heat up and boil rice for us. Okay children, so isn't it a very great application of both the solar energy as well as concave mirror? Yes, of course, we can do wonders with solar energy and hence save other sources of energy in this manner. Children, we have come to the end of this session. So, before concluding, let us look at a quick review of what we have learnt today. In our class today, we have learnt about the mirror formula. 1 by f is equal to 1 by v plus 1 by u. Focal length, f is the focal length, v is the image distance and u is the object distance. Then we have learnt about sign conventions, very important for us. The first rule of sign convention says all measurements to be taken starting from the pole of the mirror. The second rule says measurements taken in the direction of incident ray are positive and in the opposite direction of the incident ray are negative. Measurements taken above the principal axis are taken positive and below the principal axis are taken negative. So, measurements in the upward direction are positive, measurements in the downward directions are negative, very simple. And then we saw the formula for magnification, m is equal to hi by ho and it is also equal to minus v by u. Magnification is defined as the ratio of height of the image to the height of the object. Children, here are just a few questions for you to improve your learning. Find the distance of the image when an object is placed at a distance of 10 centimeters in front of a concave mirror whose radius of curvature is 8 centimeters. Children, try to solve this problem. It is from your textbook, a very easy problem. You just have to substitute. Here we have taken radius of curvature, you have to find out focal length. Then find the magnification in the above problem. Take the same problem, after finding the image distance, find the magnification. Then write down the sign conventions for the spherical mirrors. We have learnt 3 different sign conventions. You learn them and write them without saying. So, children, I hope you have understood clearly what all we have learnt in this chapter. Happy learning, children. Let us meet in the next session with many more interesting concepts.
शुभोदय बच्चों, हिंदी की कक्षा में आपका स्वागत है। बच्चों कैसे हैं आप? ठीक है ना? चलिए सबसे पहले हम वीडियो देखते हैं।
टैंग 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 सुनो घंटी बजी स्कूल की, चलो स्कूल तुमको पुकारे। पल 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 रोशनी जो मिली स्कूल की, जगमगाओगे तुम बन के तारे। कॉपी और किताबें सारी।
स्कूल देगा, स्कूल देगा,
यूनिफॉर्म भी तुम्हारी।
स्कूल देगा, स्कूल देगा।
स्कूल अब घर से दूर नहीं है,
कम हो गए फासले,
पहुंचोगे स्कूल के गेट पर तुम।
थोड़ा सा भी जो चले,
प्यार और नरमी से तुमको पढ़ाएंगे टीचर है ऐसे भले।
सच 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 रीत अब है यही स्कूल की, कभी टीचर ना बच्चों को मारे।
देखा ना बच्चों आपने, बड़ा मजा आया ना वीडियो देखकर। स्कूल